Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM Trial paper with year 2021 for SBP, Sensor Scholar Asrama Penuh, paper 1. All right, let's go straight to the first question. Okay, the first question is for Form 4, Chapter 2, Quadratic Function. So here we're supposed to find the value of alpha plus beta. You're given a quadratic equation in the form of 3x squared minus 5x minus 7. You're supposed to find the value of alpha plus beta and alpha beta. So here we know we have to use the relationship between alpha, beta, and a, b, c. Now, when you write quadratic equation, it's actually written in the general form, ax squared plus bx plus c, where a represent the coefficient of x squared, b is a coefficient of x, and c is your constant. So in this case, your a is now 3, your b is -5, and your c is -7. So you're going to link them up. The relationship between your alpha plus beta and your a, b, c is given by this SOR, which stands for sum of roots, is alpha plus beta equals minus b over a. For my alpha and plus beta, we do not know, so we're going to leave it like this. Your b is now -5, your a is 3, answer is 5 over 3. Now, whereas for your POR, product of roots, it is given by alpha times beta equals c over a. So my c is now -7, my a is now 3. So for part A, we're just finding alpha plus beta and alpha times beta. That's it. Okay, second part, hence form a quadratic equation with the roots of 2 alpha and 2 beta. Now we can say, we can call this your new sum of roots. We already know that the new roots are 2 alpha and 2 beta. The sum of root means we take these two roots, we add them up. Now I need to use a result from part A. We know that alpha plus beta is 5 over 3. So you're going to take out the 2, factorize it, you're left with alpha plus beta here. And my alpha plus beta is now 5 over 3. When you multiply together, you get 10 over 3. Whereas my new POR will be 2 alpha times 2 beta. Since your roots are 2 alpha, 2 beta, POR means product roots. We multiply together, you get 4 alpha beta. And my alpha beta is already given here as -7 over 3. So we're going to sub inside, and you will get -28 over 3. Okay, to find to form the new equation with the roots of 2 alpha, 2 beta, we have to use this formula. The formula works like this: x squared minus sum of root, SOR, multiplied by x, plus product of root, POR. The result is equal 0. Since I already have my new SOR is 10 over 3, I substitute inside. My POR, new POR is -28 over 3, I sub inside. Let us multiply everybody by 3, 3x squared minus 10x minus 28, and your outcome must equal 0. Yeah, remember, we need to multiply by 3 because most of the time we need to leave our answer in this form. But here the question didn't mention that A, B, C are usually written in the form of an integer, right? So just multiply 3, get rid of the fraction, leave your answer in this form. Okay, question number 2 is from the Form 4, Chapter 1, function. So here you're given function fx and gfx, and you're supposed to find f inverse. Okay, the two different ways to find f inverse. You can either let fx be y, or you can let f inverse x equals to 1. Now, I happen to like the second method. This is the textbook, the current textbook method, right? This is the old textbook method. Yeah, I like the old textbook method because for me, this is much easier, especially when you want to find f inverse 3 or f inverse 5. You can find the value of f inverse without inversing the function. But irregardless, yeah, whichever method, yeah, it's up to you. You can, for the differences, this one we're making y as the subject, this one you're making x as the subject. Okay, so when you let f inverse equals to y, it actually works like this. We start from x, we go backwards, you end up at y. So x is your object, y is your image. But when you interchange it, we start from y, yep, we go forward. Y is your object, x is your image. So I'm going to interchange this and write fy equals x. Now we know fx is x over 4 minus 3. Fy will be y over 4 minus 3. The result is now equals to x. So bring the 3 over, y over 4 is now x plus 3. When you multiply over, your y is 4x plus 12. And what's your y value? Your y is your f inverse x, which is now 4x plus 3. Okay, yeah, not difficult. Now, the second part. Now we want to find gx. Okay, there are actually two ways to do the gx as well, to find the function inside, or in this case, the function outside, given the function inside. Now, when I say function inside, means a function that happens first. When you have g fx, it means fx occur first, followed by g. This is a composite function, g fx. So if you're using substitution, we let fx becomes y. Yeah, I can show you two methods. The method one is substitution. Method two, it is what we call inverse. Yeah, in this case, actually, inverse method is much easier because we already found the inverse function. But since I think a lot of students, they learn the substitution method in school first. So I'll show you my substitution first, then I'll show you the inverse. Okay, substitution method works like this. We always let the function inside. In this case, fx becomes y. You can see this is your fx here, and it's now y. So if you sub in gy, is now x. Is now x over 2 minus 7. Now here's the thing. We don't write fx now, we write this as y. Your gy is now x over 2 minus 7. And I'm finding gx. Before you find gx, you must find gy. To find gy, I must change all the x into y. So we have to go back to the relationship between x and y. Okay, maybe I write this over here. I write gy over here. Gy equals to x over 2 minus 7. Now you go back to your fx. My fx is x over 4 minus 3, and it's now y. Bring the 3 over, x over 4 is now y plus 3. X is now 4y plus 12. Now notice this is actually exactly the same as your inverse, right? It's just that now it's written in terms of y. So I'm going to put the 4y plus 12 over 2 into here. Replace your x with y, minus 7. Your gy is now 4y divided 2 is 2y, you plus 6 minus 7. Your gy is now 2y minus 1. Therefore, your gx is 2x minus 1. Okay, now, second method, method 2. If you want to use the inverse method is actually easier because I already know my f inverse. And you're given gfx. In order to find g, I must put f inverse inside here, right? I replace my x with f inverse. But if I put f inverse inside my x here, I must put the same f inverse inside the second x on the right. So the f inverse that we have here is 4x plus 12. You divide by 2, and then you minus 7. Now, by the way, why do I do that? Because these two, f and f inverse, will cancel each other out and get gx. Yeah, I wonder whether you know this. When we have f and f inverse, it simply means I start from x, I go backwards, I end up at y. Let's see. Then I follow on by writing fy. That means I move forward starting from y, I'll end up at x. So notice f inverse x is like you move backwards, then you move forward. You always end up the same place where you started, which is x, right? So that's why this f inverse, we can cancel them off and just write this as x. So when we simplify this further, we got to simplify the right-hand side as well. 4x divided by 2 is 2x. 12 divided by 2, it gives us 6. You minus 7. So my gx is now 2x minus 1. There you go. You get the same answer. Okay, part C. You're finding gf inverse 2. Okay, gf inverse 2. Now we know our f inverse already, which is this. Okay, I'm going to start off by putting 2 inside. So 4 times 2 is 8. 8 plus 12 is 20. So take 20, sub inside your gx, whether it's the one above here, this one, or you can write this one, doesn't matter. So it's 2 times 20 minus 1. 2 times 20 is 40. 40 minus 1, the result is 39. Okay, question number 3. This is from chapter 6, linear law. So here we are given a non-linear function in the form of y equals to b square root x minus 5 over square root x. And we're supposed to convert to linear form. There are two ways you can convert to linear form, either using first method here. You notice the first diagram, we make y square root x as your big Y. Now, big Y means the variable on your y-axis. Okay, but you notice your y-intercept is now -3, but I do not know what's my big X. So we can convert this to y square root x by multiplying everybody by square root x. So when you multiply by square root x, you get y square root x. And remember, square root x multiplied by square root x, it will give us x. So this is bx. And your 5 over square root x, when you multiply square root x, it'll cancel out and it'll give us just 5. But remember, there's a negative in front. So this is your big Y now. This is your gradient. This is your big X and your C. That means my y-intercept is -5. So what I need to do is to compare my y-intercept from the graph, which is m-3, with the y-intercept from the equation, which is -5. Bring it over, my m is now -5 plus 3, -2. So this is the first method to convert to linear form. There's another way we can convert this to linear form. But you notice it's given in the second graph. I do not know what is my big Y, but I do know my big X is 1 over X, and my y-intercept is 1 minus m. So again, starting from the same equation, instead of multiplying by square root x, I divide by square root x. Okay, picture this. This y here, okay, let me write this here. Y equals to, let me write over here, y equals to b square root x minus 5 over square root x. So when you divide by square root x, this is y over square root x. Square root x divided by square root x, you can cancel out, right? So when you cancel out, you're left with what? You're left with b. Now that 5 over square root x, when you divide with square root x, dividing with square root x is the same as multiplying with 1 over square root x. You can cancel them and left with what? You're actually multiplying them together, you're left with 5 over x, right? So this is -5 over x. Okay, I would like to rearrange it and put my -5 in front, 1 over x at the back, and my y-intercept is now b. Now again, this is your big Y, this is your gradient, this is your x, and your c. Okay, I know that my y-intercept is now b. You compare with the y-intercept from the graph, which is 1 minus m. I know my m is -2. So 1 minus -2, my b is 3. Question number 4, this is Form 5, Chapter 6, Trigonometric Function. So given sine alpha is -p, tangent beta is q, both alpha and beta are in the same quadrant. Now notice, actually maybe the question should mention that p and q are positive constant, right? So, and we can tell from here, if p is a positive constant, your sine will be negative, right? And your tangent is positive. Now, if they have alpha and beta in the same quadrant, right? Remember ASTC, all sine cos tangent are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cos is positive in quadrant 4. So if your tangent is positive and your sine is negative, it has to be in quadrant 3. So we have to draw these two triangles in quadrant 3. So let's start with alpha. I'm going to draw my alpha like this. This is your general angle. Yeah, this is your reference angle. Your reference angle is a small angle here. All right, your sine is given as -p. So we think, remember, sine is opposite over hypo. My opposite is -p. This is your opposite here. Your hypotenuse is 1. So I need to find my adjacent value. To find adjacent, I take use your calculator. Well, use your calculator. Count mentally. Sorry, 1 minus -p square. Now notice what happened to the -p. It actually looks like this: 1 minus -p square. So it's 1 minus p square. Yeah. So, and we put a negative in front. Now, the reason why I have to put a negative in front because it's on the left-hand side of the y-axis. Okay. For the second triangle, beta is also in quadrant 3. I draw the same orientation here. This is your beta. And tangent is a ratio of opposite over adjacent. That means my opposite is Q, adjacent is 1. Now, please put a negative in front. Why? Because on the left-hand side of the y-axis, and you put a negative in front of 1 because it's, negative in front of 1, and you put a negative in front of Q because Q is below the x-axis. Right? If it's in quadrant 3, your x and y are both negative. As for your hypotenuse is always positive, so you put a square root. You can write q squared plus 1. You can write 1 plus q squared, doesn't matter. A reason is plus because it's the longer side. We take negative q, we square it, we put negative 1, we square it, we put a square root over, both positive, q squared plus 1. Okay, now that I've got these two triangles done, next, I want to find sine beta plus 90. Okay, so here we get to use the sine A plus B formula, the addition formula. It works like this: sine A cos B plus cos A sine B. Okay, my A is beta. Let's write beta. My B is 90 degree. So cos 90. And then cos A, which is cos beta, sine 90. Okay, what is cos 90? Well, cos 90, we can use a calculator, right? Cos 90 is actually 0. And sine 90 is 1. If you cannot remember, you can use a calculator. Now, for beta, we have to read from this triangle. As you can see here, sine is a ratio of opposite. My opposite is negative q. Hypotenuse is square root q squared plus 1. Cos beta is your adjacent. Adjacent is negative 1 over square root q squared plus 1. So we're going to put sine beta first, negative q, square root q squared plus 1. Cos beta, cos 90 is 0. Cos beta is negative 1, square root q squared plus 1. And sine 90 is 1. So in this case, you can cancel this out because when any number times 0 is still going to give us 0. I'm left with negative 1 over square root q squared plus 1. All right. So for part B, I'm finding tangent to alpha. Okay, tangent to A formula. How you remember? Tangent to A formula is given by 2 tangent A, 1 minus tangent square A. This is given exam. But instead of using A, I'm using alpha here. Now, when you read tangent alpha from this triangle here on the left, tangent is a ratio of opposite over adjacent. Good news, we can cancel the negative. So it's just P over square root 1 minus P squared. So I'm going to put here P over square root 1 minus P squared, divide by 1 minus P over square root 1 minus P squared squared. Okay, so let's multiply this together. 2P, 1 minus P squared. The moment you square this, this is 1 minus P squared over 1 minus P squared. So the problem is we have to simplify it. So we should multiply top and bottom with 1 minus P squared. All right. Now, I know some people find this a bit hard to see. Maybe perhaps I show you a bit more step. I show you how to, combine or simplify your numerator, your denominator. This one is 1 minus P squared over 1 minus P squared. Maybe this is easier to understand. And this will give us 2P square root 1 minus P squared. Now, I'm going to do this a bit fast. I'm going to flip this upside down. 1 minus P squared over 1 minus 2P squared. Yeah, because 1 minus P squared over here is actually 1 minus 2P squared. So I'm going to flip it upside down. And notice that this one you can actually cancel them. You can cancel this. But you're not canceling the whole thing. It's like if I give you a 1 over square root x multiplied square root x, you actually get square root x. Yeah, because this is square root x by itself. When you divide by square root x, you get square root x. Yeah, x means x power 1, square root x means power half. You divide power half, you're left with x power half, which is root x. So that's what I'm going to do here. I'm going to simplify this, cancel or simplify this two, left with 1 minus P squared, divide 1 minus 2P squared. Yeah. The formula part is not that difficult. It's just simplification, involving algebra. Okay, next question, question number 5. This is Form 5, Chapter 4, Permutation and Combination. So the first part. So how many ways we can arrange, find the number of different ways to arrange all the letters in a row without repetition. So here we have 6 different letters. from the word rohani. So I hope you really know if you have 6 different letters, right? If you were to use the slow way, we say that the first box, you have 6 options. You can choose any one of the 6, right? If you take one letter out, you're left with 5. For example, I take letter H out and I put it here. Then I got 5 other letters to choose from. Let's say I take letter A, I put it here. I got 4 more letters to choose from, right? I put letter I, 3 letters to choose from, 2 letters, and 1. So we can actually multiply them together one by one. 6 times 5 times 4 times 3 times 2 times 1. Or we can say 6 factorial. And the factorial sign you can find from the calculator. It looks like this: 6 shift factorial. There you go, 720. Yeah, your answer is 720. Okay, the second part. The vowel have to be side by side. Okay, the method in finding a number of ways such that vowels are side by side is that we tie the vowel together. The vowel in this case is given by O, A, and I, right? I still have 3 other letters which are consonant: R, H, and N. So how many ways we can put 3 letters O, A, I next to each other? So it goes 3, 2, 1, or you can say 3 factorial. The idea is to tie this together as a block. Yeah, think of it as a block. And I want to arrange one big block of vowel with 3 other consonants in a row. So to do so, there are basically 4 blocks to arrange. So the first one, you have 4 options. Second one, 3. Third one, 2. Last one is 1. So the number of ways to arrange them, now we can actually write like this: 3 factorial ways to arrange a vowel multiplied by 4 factorial ways to arrange 3 blocks, 3 consonants plus a block of 3 vowels. That's why it's 4 factorial. Answer, we can use a calculator here. All right, 3 factorial multiplied by 4 factorial. There you go, 144. Okay. All right. So the first part, I think, is quite easy. The second one, part B. The vowels and consonants are alternate after 2 new cards labeled A and H are inserted into the set of cards. Okay, now they put 2 more cards, H and A. So in this case, you got 2 letter A, 2 letter H. You still have R, O, N, and I, right? So here's the problem. We got identical letter now. So remember, if you have arrangement of non-identical item, we can just say if you have 6 letters, 6 factorial. But if you have identical item, you're going to divide by the number of times the identical item appear. If the identical item appear 2 times, you divide by 2 factorial. If the identical letter appear 3 times, we divide by 3 factorial to cancel out the arrangement. Okay, so here's the thing. Now I have 8 letters, okay? And you want it to be alternate, right? Alternate means what? I can start with consonant, vowel. Remember, originally I have 3 consonant, 3 vowels. But when I add 2 letter A, 1 letter A, 1 letter H, I got 4 vowel and 4 consonant. We have equal vowel and consonant. Remember, these are vowel. This one is vowel, vowel, vowel. You got 4. Consonant, consonant, consonant. You got 4 as well. So you can start with consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel. Now we can do the other way around as well. 1, 2, 3, 4, 5, 6, 7, 8. We can say vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. But for me, I just find one way. How many ways this thing work? And then I just multiply by 2, right? If you have equal number of consonant, vowel, yeah, the number of ways arranged, then yeah, always double. You can do consonant first, vowel later. If you have 1 consonant more than vowel, then you don't have 2 ways. Yeah, you can have, let's say for example, you have 4 consonant, 3 vowel, then it looks like this, where the vowel must be sandwiched in between the consonant. Okay, coming back to this. Okay, how many consonant do you have? 4, 3, 2, 1 ways. How many vowels do you have? 4, 3, 2, 1 ways. So, but of course, you're going to multiply by 2. Okay, remember, this is arrangement without identical item. So we can say it's 4 factorial ways to arrange the vowel times 4 factorial ways to arrange the consonant. Then I times 2 because I can start with a consonant followed by a vowel. or I can start with vowel followed by consonant. However, because you have two identical letter A and two identical letter H, that's why I must divide by 2 factorial, 2 factorial. Yeah. For those who are not sure why, let's say I have Rohani. Okay, Rohani. Let's say A, Rohanian. Yeah. So let's say if I put the first letter A, I put A1, and second letter A, A2. But when you put letter A first, followed by this, you put the second letter A, followed by first letter A. Now this one appeared to be different arrangement. But the moment you take away your, subscript for letter A, so what happened is, oops, Rohani, Rohan, they appear to be the same thing. That's why we're going to divide by 2 factorial to clear or cancel out the number of identical arrangement for the 2 letter A. But we're going to do the same for the 2 letter H. This is H1, H2. This is H2, H1. They appear to be the same, to be different, but when you take out the subscript, they appear to be the same. All right, so what we need to do is just to divide by 2 factorial twice. Yeah. Okay, let's do this. I'm going to start with 4 factorial, multiply with another 4 factorial, I times 2, divide by 2 factorial. Actually, you don't have to type 2 factorial because 2 factorial is just 2. Okay, I'm just going to type out for you. All right, my answer is 288. All right. Okay, question number 6. So here we have a swing that is tied, a swing net tied between 2 tree trunks. So both ends of the swing rope are tied at the same height, 210 cm, and the distance between the tree is 200 cm as 200 cm here. The height of the swing in the middle of the net of the tree is 100 cm from the level of the height of the rope tied between the trees. So what we're saying is this. Okay, I know it'll be hard to see. Let me redraw using a graph like this. These two are at the same level at 210. All right. So this length from here to here is 200, right? And the height is below 100 cm from the level of the height of the rope tied between the trees. So that means 210 minus 100, this is 110. So what we want to do is we want to represent this using a quadratic function. Okay, in fact, the first one, we are stating the equation of axis of symmetry. I've already drawn this line for you. This is the middle line. Axis of symmetry is a line that divides the graph into 2 equal halves. So your axis of symmetry, the question already asks you to assume the tree A is the y-axis and the base at the origin. So that means we can map it like this. That is your big Y, is your X, this is your Y, your X. All right. Your axis of symmetry is X equals 100. Yeah, the line right in the middle. Now, how do I know it's 100? I take 200 divided by 2. Yeah, it's right in the middle because it's 0. Or some people may say, should I write 0 plus 200 divided by 2, X equals to 100? Yes, you can, right? Since it's 1 mark, you don't really have to show this working here. All right, second one. Find the equation of parabolic swing rope fx. That means you're using a quadratic function to represent the swing. Okay, so we know a general form of a quadratic function is we call it a vertex form, is given in this manner. Now, the thing is, I already know my axis of symmetry. Your axis of symmetry is 100, so I put 100 here, right? Okay, and remember it's always minus. It's always minus, and it's always minus P. So P is your axis of symmetry. And how about your Q? Q is your vertex, the lowest point. In this case, 110. Well, I actually got the answer here, but I need to find my A. The A is missing. We need to use a point. Now, obviously, we can't simply use any point. You can't use 110 because if you try to put 0 and, if you put 100 inside, for example, if I put 100 inside here, what happens is 100 minus 100 becomes what? 0, right? So we cannot find the value of A. We can't find A if I use this point here. So we're going to use another point. In this case, I think the best point to use is this one. right? Or you can even use 200 and 210. I would sub in 0 and 210. That means my y is 210, my x is 0. Okay, so 100 square is 10,000. Bring the 110 to the left, right? So 210 minus 110 is just 100. So A will be 100 divided 10,000, answer 1 over 100. So my function fx is now 1 over 100 x minus 100 square plus 110. Okay, that is your answer. All right. So question never asks you write in any form, but we can actually write in this form, the vertex form. I think it's good enough. Okay, next one. The quadratic equation produced has no real root. Show your calculation to support the statement. Actually, they should say the quadratic equation fx equals 0 has no real root, right? Because it's a quadratic function, it's not a quadratic equation, right? So we know it has no real root because it doesn't cut the x-axis. Okay, well, actually, you can try to solve it and it got no real root, but normally to show that it has no real root, we use b squared minus 4ac. So I'm going to rewrite this 100. Let's expand this, x squared minus 200x plus, this is 100 square. You can write 10,000 if you like, but because I know I'm going to expand it, so when I expand it, this will be 1 over 100 x squared minus 2x plus 100 plus 110. Okay, so this will give us equal 0 here, x squared 1 over 100 x squared minus 2x plus 210 equals 0. Okay, so to show that it has no real root, normally we use b squared minus 4ac. So I'm going to write, sorry. Okay, I'm going to write this over here. Okay, further to the right, your b is negative 2 square 4ac 210. Let's use our calculator. Minus 2 square is 4, minus 4ac. My a is 1 over 100. My c is 210. There you go. I got negative 2205. Yeah, negative 2205. So this is less than 0. So if it's less than 0, what does that mean? Meaning there is no real root, yeah, for this equation. Yeah, that's all. Yeah, because the question asks us to show your calculation to support your statement, so we do b squared minus 4ac. Yeah, show that it's less than 0. Yeah, and we conclude that there is no real root to this equation. Okay, question number 7. This is from 5, chapter 3, integration. Okay, the first question is very interesting. Integrate, find, you're given, okay, let me explain the whole thing. Given that y equals x plus 1 over 3x minus 2 and dy dx is 1 over 4 gx. Yeah, gx is a function in terms of x. State the value of this integral. Okay, we know one of the law of definite integral is that it doesn't matter what function you have, when you integrate from a to a fx dx, your answer is always 0. Yeah, because if you, let's say you integrate, then you get the result is gx. Your lower limit is a, upper limit is a. When you sub in, you are getting ga minus ga, which is going to give us 0, right? Okay, so what is the answer for part A? Well, your answer for part A, we can just write 0, right? It's just 0. You want, you can write, copy the question, m to m, gx plus m dx. Yeah, the whole thing is just 0. Okay, B. Find the value of k if the integral of 0 to k gx dx is now 5. Okay, before you find the definite integral, understand this. When you differentiate a function, you get, should I write like this? When I differentiate this function, x plus 1 over 3x minus 2, I will get 1 over 4 gx. So when I integrate 1 over 4 gx, I will get this function, x plus 1, 3x minus 2 plus c, right? But here I want integration of gx. So basically, you just take this and multiply by 4. Now you can times the 4 inside straight away, or you can just keep the 4 outside. It's up to you. I just put 4 inside, 4x plus 4. Okay, now I want to find integration of 0 to k gx dx. So when you integrate 0 to k gx dx, meaning we need to sub in the limit 4x plus 4, 3x minus 2, 0 to k. And this result is now 5. So I put a 5 here. All right, let's put k inside. So it's 4k plus 4. Yeah, this is 4. And then 3k minus 2. When I put 0 inside, I don't get 0. 4 times 0 is 0, but then there's a 4 here. 3 times 0 is 0. There's a minus 2 here. Remember, we are putting 0 inside of x, inside x here. First, we sub in the k inside the x. Then we sub in 0 inside x. Okay, so let's simplify further. This is 5. Now, I think the 4k plus 4, I'll leave it first. 3k minus 2, I'll leave it. This is 4 over 2, which is negative 2. There's another negative, so it is going to give us a plus 2. So bring the 2 to the left-hand side. 5 minus 2 is 3. So I write 4k plus 4, 3k minus 2. This is 3. Multiply over 4k plus 4 is 9k minus 6. Bring over 9 minus 4 is now 5. 4 plus 6 is now 10. My k is 2. Okay, it's quite long. All right, second part. I need to find, this is only B Roman 1, B Roman 2, find the value of k when we integrate from negative 1 to 4 gx plus k dx. It is now 37. Okay, so we first break this up. Negative 1 to 4 gx dx. All right, I'm going to my plus k, integrate negative 1 to 4 k dx. This is 37. Okay, now next, this integration negative 1 to 4 gx dx, right? We can use the result here again. We put in 4x plus 4, 3x minus 2 from minus 1 to 4. And when you integrate k, you actually get kx. K is a constant. When you integrate constant, we add x, negative 1 to 4. The result is 37. Let's substitute 4 inside. 4 times 4 plus 4, 3 times 4 minus 2, minus here, 4 times minus 1. You can write minus 4 straight away, but never mind, I'm just going to write this for you. 3 minus 1 minus 2. And this will give us 4 times k minus k times negative 1. So it's negative 1k, yeah? Negative k here. So yeah, be careful, minus minus is a plus here. So this is 16 plus 4, which is 20. 20 divided by 10, I got 2 here. Yeah, you can't do mentally. Please use your calculator. And this is just 0, because minus 4 plus 4, this is just going to give us 0. And you have a 4k minus minus k. This gives us 5k. The result is 37. 5k is now 37 minus 2. 35. K is just 7. Okay, question number 8 is from 4 chapter 7, coordinate geometry. So diagram shows a rectangle ABCD. Find the value of alpha. So if this is a rectangle, actually there are 2 ways to do it. You can use midpoint, or you can use m1 dot m2 equals to negative 1. Yeah. Since you can see this is a rectangle, this is 90 degree, and I think maybe I'll just use m1 dot m2 because we can see BA and AD, they are perpendicular. Now we can also use BC or NCD. Let's use BAAD because it's easier. We know gradient AB multiply with gradient AD, the result is negative 1. This is true when 2 lines are perpendicular to each other. For gradient AB, right, I like to use negative y-intercept over x-intercept. It's easier. Now, my y-intercept is 1. Yeah, coordinate point B, the y-intercept is 1. My x-intercept is just A. In this case, alpha. And your AB, I would have to use, remember, we can find gradient by using y2 minus y1, x2 minus x1. My y2 is 12, my y1 is 0. My x2 is 5 alpha, my x1 is alpha. The result is -1. All right, so, sorry, I wrote wrongly. This is, 12 alpha, 12, wait, I think I wrote this wrongly. 12 minus 0 and 5 alpha minus alpha. Okay, sorry, it's nothing wrong. So what we have here is, we can cancel negative, negative. So this is 12, this is 4 alpha. 5 alpha times -1 is 4 alpha. 4 alpha times another alpha is 4 alpha squared. This is 1. So alpha squared. Okay, guys, I realize there's a mistake in the question. This is, if you cancel it, is 3. The alpha squared times up is alpha squared. So alpha is 3 because alpha is on the right-hand side, so it's positive. So there's a mistake in the question here because you notice if I use m1 dot m2 equals to -1, your alpha is 3. Okay, so but if I go and use gradient AB equals to, let's say, gradient CD, I think I'll be able to get this answer. So AB is the same -1 over alpha. Gradient CD, I will use, for example, 13 minus 12, or maybe I use 12 minus 13. 12 minus 13 divide 5 alpha minus 4. So this -1 over alpha, this is -1 over 5 alpha minus 4. So when you compare your denominator, you can cancel the -1, right? Bring this over, 4 alpha equals to 4 alpha is 1. Yeah. Okay, you notice the marking scheme gives this answer, but obviously there is a mistake in the question. Maybe they shouldn't say it's a rectangle. They should say it's a we call it a parallelogram, because it may not necessarily be 90 degrees. But if it's a parallelogram, these two are parallel, then the gradient of AB, yes, is the same as gradient of CD, but this concept, this one cannot apply. Yeah, maybe they shouldn't say it's a rectangle. Like I say, it should be a parallelogram. Otherwise, you will get 2 different answers, right? So I'm just going to take this as a parallelogram, right? So we use alpha equals 1 instead of 3. Okay, next one. They say the coordinates of E when DA is extended to point E such that ED DEA is 6 to 2. ED EA. So I don't know where is E. Probably here. This is ED EA is 6 to 2. Let me drop this off. This is 6. This is 2. This is 4. Now, even then, I don't want to use 2 and 4 because the number is a bit big. So we can actually even simplify this and use divide by 2, I get 1. Divide by 2, I get 2. This ratio is just 3. Yeah. Instead of using 6 to 2, might as well we use this one would be 3 to 1. Yeah. You can simplify to the lowest term. All right. It doesn't affect the answer. Okay. So we're going to let E be, let's say, x1. We already know your alpha. Your alpha is 1. All right. So this D is 5, 12, right? Okay. Remember, when you're given a point that divides a line segment according to 2 parts here, so we use the formula xy equals to mx1 plus mx2 n plus n, and then ny1 plus my2 over n plus n. Okay, xy should be a point in between, in this case, 1, 0, point A. Your n and m, remember, they must be on the, let's say m is here, n is here. The coordinate and the ratio must be opposite. So when you multiply, you take n, multiply x1, m, multiply x2. Yeah, that's the important thing that to know. You must multiply with the opposite coordinate. So let's start with n, 2. I multiply with x. And then m is 1, I multiply with 5. My total ratio is 3. Yeah, total ratio is m plus n. Then we continue with 2, multiply with the y coordinate y. 1 multiply with 12, total ratio also 3. So let's solve these two separately. We can write 1 equals 2x plus 5 over 3. multiply over 3 equals 2x plus 5. 2x is now -2. My x is -1. Likewise, I compare my y coordinate, 2y plus 12 over 3. 3 times 0 is still 0. 2y plus 12 is 0. 2y is -12. Y is -6. So therefore, your coordinate of point E is -1, -6. Question number 9, this is from chapter 4, indices and logarithm. The first part is the logarithm. You're given log base 7, 3 is k, 7 power 3y minus 1 is 21. So you're supposed to express y in terms of x. So it's always easier to change from logarithm form to index form and then be solved using initial equation, if you like, to call it. So we know log base ay is now x, y is a power x. So we say your 3 is 7 to the power k. Now let's look at the second equation. We have 7 power 3y minus 1 is now 21. Now you gotta think 21 can be broken down into two numbers, which is what? 3 times 7. Since my 3 is 7 power k, I can multiply with 7, right? I replace my 3 here with 7 power k. And I multiply with 7 power 1. Here, 7 means 7 power 1. Now, in law of indices, we know that a power m times a power n, we group them together is a power m plus n. In this case, 7 power k plus 1. Now, we have 7 power 3y minus 1 on the left, 7 power k plus 1 on the right. We basically compare the power and make y as a subject. Bring a -1 over. I got k plus 2. My y is k plus 2 over 3. There you go. You got your y in terms of x. Moving on to b. Here, you're supposed to solve this equation, right? 5 power x squared over 25 power x plus 1 is 1 over 25. So for me, I will change everything to base 5. It's quite clear cut. 5 power x minus 1, I leave it. 25 is 5 power 2. There is a x plus 1 here. 1 to 5 is 5 power 3. Okay, let me do one by one. Now, you all know that a power m bracket power n is a power m times n. So there's a 5 power x squared here. All right, you got to divide by 5 power 2x minus 2. This 1 over a power n, when you bring it up, is a power negative. So it's a power negative n. In this case, 5 power -3. So when I bring this up, I got 5 power x squared, then you minus 2x. Now minus, remember, it becomes a plus 2. This is 5 power -3. So let's compare. X squared minus 2x plus 2 is now -3. Bring the -3 to the left-hand side. Your x squared, sorry, this is -3. Yeah? So this is a plus. I made a mistake here. Sorry, it's a plus here. This one is a minus here. It's a minus here when you divide. When you bring the -3x to the right, you get x squared minus 2x plus 1 equals 0. So we can actually factorize this using the form of what? A squared plus 2ab plus b squared. When you factorize it, is a plus b squared. So I write x minus 1 squared equals 0. Your x is just 1. Okay, moving on, question number 10. This is from 5, chapter 1, circular measure. So diagram 5 shows a semicircle with center O and radius of 10 cm. So we know this radius is 10, 10, 10. All right, you're supposed to find the length of arc BC in terms of alpha. This is your length of arc BC. Okay, so first of all, I know if this is alpha, because these two are equal length, this is also alpha. So your angle BOC with BOC here, I must take 180, but 180 is degree, in radian is pi, minus alpha. We can say pi minus 2 alpha. So to find length of arc BC, we use S equals to r theta. My r is my radius, which is 10. My theta is now pi minus 2 alpha. So when you put them together, multiply, you get 10 pi minus 20 alpha. There you go. That is your length of arc in terms of alpha. Okay, then it is given that the length of arc AB is equals to radius of the semicircle. Okay, length of arc AB is actually here, right? It is equal. So that means this is also 10 cm, right? We are supposed to find the area of shaded region. Okay, the reason why they give us this is to help us to let us find the value of theta. Now we know by using S equals R theta, your length of arc is 10, your radius is also 10. That means your theta is 1. In this case, 1 radian. If your theta is 1 radian, right? So we can actually find angle BOC. Yeah. Angle BOC in this case, since this is a straight line, yeah, total angle for a straight line in degree is pi, in degree is 180, in radian is pi. So we take pi minus 1. Now, take note, we have to use 3.142. So if you take 3.142 minus 1, you get 2.142. So that is your angle BOD, 2.142 in radian. Okay, to find area shaded region, basically we are finding area of segment. Now, I don't know whether you know this. Segment consists of a sector minus a triangle. Now we can use a formula here. Area of a sector is half r squared theta. Area of triangle, we can use half AB sine C. Your AB are r and r. R times r is r squared sine theta. We put them together, we put half r squared theta minus sine theta, right? So this is a formula that we use to find area of segment. So my radius is 10. My theta is now 2.142 minus sine 2.142. We can do that, but make sure you use your calculator in radian mode. So I'm going to show you here. Change your calculator to radian mode. Shift mode number 4. Take half. Your radius is 10. You square it. 2.142 minus sine 2.142. Close bracket, right? My answer is 65.04. Yeah, 65.04. Now you can choose to do one by one, but I don't like to do one by one because it's very slow. Yeah, some people, they divide this even their center, they find the height, they find the base. Don't need to do that. It's very slow, right? This half r squared theta minus sine theta is a very, very useful formula to find area of segment. Okay, question number 11. This is from 4 chapter 8 vectors. All right. So here we have a diagram that shows the plan of a factory plan area in a Banting Selangor. So we have trapezium PQRS. Now this is a bit small. I may have to zoom in first. Okay, a bit small to see. Right. Okay, it is given that trapezium PQRS is the area for PAD4. All right, the distance PS, TS, QR, PQ, they are. PS is, sorry, let me write using red pen, easier to see. Your PQ is 600 meter. PQ is here, 600 meter. All right, your TS is 150 meter. So very small length here. TS is over here. And then QR is 900 meter. QR is 900 meter here, from measure from here to here. And then lastly, PQ is 400 meter. Lastly, PQ, sorry, PS is 600 meter. PS is 600 meter. Yeah. So that means if your PS is 600, the whole thing is 600. 600 minus 150 is 450. Yeah? This is 450. Yeah? Just so you know. PS. S is over here. This is T. Yeah? This is 450. Okay. And sorry, this is not 600. This is 400. Last one, PQ is 400. Maybe hard to see. Yeah. Okay, diagram, the picture is not very clear. Okay, now let us redraw this. Redraw this. It looks like this, a trapezium. 1, 2, do a bit sharper like this. This is 3, make it a bit longer, and this is 4. Okay, so now we don't know whether this is perpendicular or not, but doesn't matter. The main thing is this is point T, this is P, this is S, this is R, this is Q. All right, now they say by using V to represent 50 meter in the direction of PS. Okay, 50 meter. So 450 divided by 50. 450 divided by 50 is 9. So I put a 9. This is vector V. All right, maybe I use a different color for this. I use say blue color. This is 9V. And then we know if this is 50 meter, 450 divided by 50 is 9. 150 divided by 50 is 3. So this is 3V. Okay, and since we know this is 900 meter, 900 divided by 50 is now 18. So this is 18V. Okay, as for U, right? U is 100 meter in the direction of PQ. So this is 400 meter in direction of PQ. So we write this as 4U. Okay, I think my diagram is okay. All right, so let me just zoom out now because it's too small. Yeah, I can't see. Now I'm going to zoom out so I have writing space to show you here. Okay, so I've got my diagram done. Next, I need to find vector PR. Okay, so to go from P to R, right, part A, to go from P to R, I can go from P to Q, Q to R. Q to R. So PQ is positive for U, and QR is 18V. So it's 4U plus 18V. Okay, second part. Point X lies on PAD such that TX is MPQ. TX is M times of PQ. Okay, when we say TX is M times of PQ, that means it's parallel. So I need to draw like this. Oops. TX is MPQ. So I don't know, maybe X is over here. Okay. And M is a constant. So express TX in terms of M and U. Okay, we can see that TX is going here. And when we say TX is MPQ, that means TX is parallel to PQ. So we know TX is M times of PQ. Since we know PQ is 4U, so this is 4MU. TX is 4MU. All right, so I've got T in terms of X. All right, next. Oh, I may have to zoom out a little bit more. Hence, if PXR are collinear, find distance TX. Okay, find distance TX given that PXR are collinear. Okay, so if PXR are collinear, so let me draw another line. Okay, maybe I just join this together. You can see it looks like this. Huh? They are collinear. All 3 points lie on the same line. So when 3 points are collinear, we can say PX is lambda times of PR. Yeah, since I already know PR, right? I already know PR. Okay, to go from P to X, I can go from P to T plus T to X, right? This is my PR. It looks a bit ugly. Okay, my PR I already know from the earlier part, 4U plus 18V. PT is very simple. We know it's 9V. TX I know is 4MU, yeah, from part B. Multiply 4 lambda U, 18 lambda V. Okay, this is V. Let me write clearly. So in order to find the value of M, we need to find the distance TX. Before you find TX, you know what's your M, right? So let's compare one by one, but be careful. This is V first, M is later. right? So you may want to rearrange it, either rearrange the left or rearrange the right, doesn't matter. Maybe I rearrange the right. I put 18 lambda v plus 4 lambda u. Let us compare our v first, right? The number in front of v, as you can see, a number in front of v is 9, and the number in front of v here is 18 lambda. So by comparing v, 9 equals to 18 lambda, my lambda is half. If you compare your u, let's compare our vector u here. I got 4m, and 4m is now 4 lambda, right? 4m is 4 lambda. Since my lambda is half, m is just half. Okay, I know m is half. So that means tx is now half of pq. Now, do we know the length of pq? Yes, we do. Right from the start, they say PQ has a distance of 400 meters. This one, 400, right? So since the magnitude of TX is the same as half times of magnitude of PQ, so I'll take half times 400. Answer is 200. Yeah. So the length of TX is 100. So this question is not difficult. It's just that maybe they should draw this a bit bigger, a bit clearer. Yeah. Yep. It's not very clear diagram. Yeah. So that makes it a bit hard to see, but you got to divide it. Yeah. You got to divide by 50, divide 100 to express everything in terms of vector U and V. Okay. Moving on. Question number 12. This is Form 5, Chapter 5, Probability Distribution. So first, you have a jar that contains 2 types of marbles, red and blue, in the ratio of 5 to 9. So 8 marbles are taken at random, 1 by 1 with replacement. Now remember, with replacement means you draw, you put back, you draw again. So the probability of getting red marble or blue marbles are always the same. So it follows the, what we call that, the binomial distribution model, right? So remember, if it's binomial, we can use Px equals to R, NCR, P power R, Q power N minus R. P means the probability of success, Q is probability of failure, N is your number of trial. So in this case, for the first part, right, we can write like this, but if you do not want to write in this manner, it's okay. Though there's no marks given for writing this. My N is 8. Why? Because I'm drawing 8 marble. Yeah. 8 times, but every time I draw, I put back, so it doesn't, the probability doesn't change. So the first part, we want exactly 4 blue marble. I want blue. So what's the probability of blue? Well, you have 9 blue out of total is 14. So it's 9 over 14. So the probability of getting exactly 4 blue marble will be, we write 8 choose 4. P is 9 over 14 power 4. Now 1 minus 9 over 14 Q is 1 minus P. Your Q is 1 minus 9 over 14. That means not getting blue, or we can just say red, like 5 over 14, right? So we write 5 over 14 here. This is also 14. Okay, there are 2 ways to do it. One, by using this calculator. I'll show you another calculator also, right? So we take 8, choose 4 times, open bracket, 9 over 14, close bracket, power 4. Then you multiply by 5 over 14, close bracket, power 4 as well. So I got 0.1945. 1945. Okay, if you have this calculator, or this calculator is a lot better, you press mode, you go to 7 for distribution, you go to number 4, binomial PD, you go to number 2, variable. All right, you write down your x is 4, your n is 14, your probability of success is 9 over 14. Yeah, in this case, you notice, wait, binomial PD, my n is, sorry, your n is 8, your p is this 9 over 14. Yeah, there you go, 0.1945. Same answer, just faster because you just key in your n, your x. That's it. Okay, second one. More than 3 red marbles are selected. Now, here's the thing. I'm now finding red. Part A, B is different. Part A, we're finding blue. Part B, you're finding red. So your n is still 8. but your probability of success is now 5/14. Okay, maybe I write over here, no more space to show you. All right, part B is still a binomial. Your N is 8. Your P is now 5/14 because you are focusing on finding rate. You want more than 3 rate marble. Now, more than 3 means what? We are referring to 4, 5, 6, 7, 8. But if you count one by one, it's very slow because you do 4, 5, 6, 7, 8, that 5 values to calculate. So the easier way is to do 1 minus 0, 1, and 2. Well, if you're not sure, I can just show you here. This is your X, this is your P. You got 0, 1, 2, 3, 4, 5, 6, 7, 8. More than 3, you are referring to this. If you want, you can count one by one, but it's very slow, right? You got to count 5 values. So, well, okay, I forgot one thing. More than 3. More than 3 means I can do 1 minus 0, 1, 2, 3. Yeah, because the total probability is 1. Everybody, we want to find this. We want to find more than 3. We want to find 4 onwards, right? But your sum of probability is 1. So we do 1 minus 0, 1, 2, 3. But if you find like there's no difference in doing this because this is 5, the other one is 4. So it's about the same. You want to count 4, 5, 6, 7, 8 and add up is still okay, right? So yeah, this is the annoying part, one by one. So your N is 8, choose 0. Your P is 5/14, power 0. Your Q is 9/14, power 8. Now for me, I like to write minus below one by one because easier to see. This next one is 8, choose 1. Your P is this. Your Q is this, just reduce by 1, 7. Then you can do 8, choose 2, 5/14, power 2, 9/14, power 6. Just reduce by 1. 8, choose 3, 5/14, power 3, 9/14, power 5. Now, I don't even want to use the calculator type this way because it's going to be very, very long. Now, one advantage of using this calculator is because this calculator has a summation, what do you call that, function. So I can press shift sum, log here, sum. I type in the general formula. Since I want more than 3, that means I want 4 onwards, right? So first I write a general formula. 8, choose alpha x. I multiply with your P, which is 5/14. This will be power alpha x, the general formula. I multiply with 9/14. This will be power 8 minus alpha x. Okay, now from here, I will just put in, I want more than 3 means 4 until 8. I press equals. There you go. I got 0.3090. Yeah, 0.3090. Very fast. And you get the answer. All right. Now, on the other hand, those who have this calculator, right? This calculator has its advantage as well because we have this binomial CD function. You go to 7, this is number 4. This is PD. PD means probability density. We go down. You go to binomial CD. CD means cumulative density. So we go to your variable 2. Okay, I want to find 5 onwards, but I have 3 onwards, but I can't find 3 onwards from here. Cumulative density is like cumulative frequency. We count from 0 to up to where we stop. So that means that if I want to find 5 onwards, I must do 3 onwards, sorry, I must do is 4 onwards. I say wrongly, 4 onwards. I must do 1 minus 0, 1 to 3, which is something similar to this, 0 to 3. So let's do 3. And your N is still 8, right? Your probability in this case is 5/14. So you press equals. Now notice that what you're getting here is 0.6910. That means we are doing 1 minus 0.6910. Now, just use a calculator. What is 1 minus 0.6910? Well, they're getting this 3090. Yeah, which is exactly the same as what we have here, right? So you either use a cumulative, like what I did here, then do 1 minus, or you can use this function, the summation function. You just add from 4 to 8, right? Okay, question 13. This is from 4 chapter 5 progression. So here we have a diagram shows part of a mural painted outside the computer room of SM Science Langkawi. So they say the radius of the smallest sector is 10 and the arc length increases by 10 by pi cm successively, and the radius of the end sector is 18.4. So you're supposed to find the length of arc of the end sector in terms of pi and then calculate the value of n. Okay, you got to understand this first. So, well, they gave us the radius and the radius increases, right? Now, this is an arc. You can see this pi over 3, a bit small. That means we know, let's say this is a circle. If this angle is pi over 3, this angle here should be total angle for one whole turn is 2 pi. You minus pi over 3, you will get 5 pi over 3. So this part here is 5 pi over 3. Now, we know length of arc is given by S equals to R theta, right? So your progression, if you look at the radius of the smallest one, okay, is 10, right? And then it increases. The radius of the largest one is 18.4. But when we talk about length of arc, you need to multiply by your pi. So the first one is 10 times 5 over 3 pi. Okay, maybe I just write T1, 10 times pi, 5 pi over 3, which gives us 50 over 3 pi. Okay, now we know our common difference. The common difference increases by pi. What question mentioned here increases by pi. So we're supposed to find the length of arc of the end sector. So we know for arithmetic, the formula is given by Tn equals to a plus n minus 1d. So my Tn is now a is 50 over 3, 50 over 3, pi plus n minus 1. My common difference is pi, right? So we are supposed to find the length of the end sector in terms of pi. Okay, but if you do this, this is in terms of n and pi. So if you want in terms of pi, since I know the radius of end sector is this, okay, maybe I can just take this and multiply by my angle, 5 pi over 3. Okay, I'm going to do this later. I will straight away say the end sector is R, 18.4, multiplied by your angle, theta, R theta. So use our calculator. Let me put it over here. 18.4 times 5 over 3. Whether you want to put a pi or not, doesn't matter. Yeah, just leave it here. 92 over 3 pi. 92 over 3 pi. So this will be in terms of pi, but without n. And then calculate the value of n. Okay, to find the value of n, I'm going to use this formula here. A, which is 50 over 3 pi plus n minus 1. My d is pi. The result, 92 over 3 pi. Okay, now I know the pi is a bit annoying. So what you can do is, you can just divide everybody by pi. I'll just cancel the pi here, see? Cancel the pi, cancel the pi, cancel the pi. So just use your calculator to find n, right? Now I'm going to use a calculator here. I basically take 92 over 3 minus 50 over 3. Yeah? You can just write 90 minus 50 over 3. Oh, sorry. One more time. 92 over 3 minus 50 over 3. Okay, what I get here? I get 14. That 14, I must plus 1, and it's just 15. Okay, first part, I got the value of n. I got the Tn in terms of pi, and I got the value of n. Okay, next. You're supposed to find the total, they say calculate the total length of the arc and straight line in the mural if 25 arcs are drawn in the mural. Okay, now we have straight line and we have the length. The straight line will be here, right? Okay, and the length, yeah, is basically this, the length of this, all this arc. Okay, now to find the length of the straight line, we need to know the difference between the longest and the shortest radius, right? So, and there are 25 arcs. So we need to know the radius of the 20, we call it the 25th, yeah? The 25th, the length of the 25th radius. Okay, let's use T25. Now we know your A is the length up for the first one is 50 over 3 pi. Your n minus 1 is 24. My common difference is pi. All right, so I'm going to take 50 over 3 plus 24. So this will be 122 over 3 pi. Now 122 over 3 pi represent the length of arc of the 25th the 25th length of arc. Okay, so I will find the radius. We know S equals to R theta. Radius is unknown. Theta is 50 is 5 over 3. So I'm going to put a 5 over 3 pi here equals 122 over 3 pi. I find my radius by taking 122 divided by 5. Okay, 122 divided by 5. I can simplify that. You want, you can change the decimal 24.4. I'll just write 122 over 5. Now, why do I do that? Because you can see the longest, if I were to draw like this, this is the longest, this is the shortest. The longest has a radius of 122 over 5. The shortest, the smallest arc has radius of 10. So I need to find this length here. And I need to find this length here. But they are basically the same length. We just have to find the difference, right? We need to find the difference. So we can say the length of the line will be 122 over 5 minus 10. All right, 122 over 5, you minus 10. It will give us 72 over 5, or you can write 14.4. Yeah, 72 over 5. Okay, so that means this length here is 72 over 5. Okay, you minus 10, you get this as 72 over 5. But to find the length of all the arc, I need to use S25. Now, for me, I like to use n over 2 a plus l, right? You can use either this formula or n over 2 2a plus n minus 1 ds. So I can use this as well. I like to use a plus l since I know the length of the longest side. The longest side is this 122 over 3 pi. So my a is now my a is 50 over 3 pi. My longest one is 122 over 3 pi. Okay, let's count. This will give us, all right, 25 over 2, open bracket. I think the pi, we can just leave it out. We can just add the pi later. 50 over 3 plus 122 over 3. So this will give us 2150 over 3. Yeah, 2150 over 3 pi. Okay, so what is the total? Okay, we start with the maybe the length of this one first, plus the straight line. But I have two straight lines I have to add. The one on top, the one below. They are both 72 over 5. So just calculate this. And the question say use pi as 3.142. So I take 2150 over 3. I multiply by 3.142. I plus 2 times of 72 over 5. There you go. Very ugly number. 2281. If you round off 2281, I think 4SF will do 2281. If you want, you can write more, 2280.57. All right, 2281. Okay, good enough. So this length is in cm. Okay, question number 14. This is from 4, chapter 7, coordinate geometry again. So you're given a circle with center C, P7. It passes through point A, 4 minus 2. The equation of tangent to the circle is this x equals to 3y plus 10. Okay, so let's do a sketch. This is your circle. This is a tangent. Yeah, they say the center of the circle C is P7. it passes through point A, 4 minus 2. The equation of tangent to the curve at point A is x equals 3y plus 10. So it looks like this. Now, when a line is a tangent to a circle, it's always perpendicular to the center of the circle. Okay, so one thing, we can start off by finding the gradient of this line. So let's change it to y equals to mx plus c. My y is 1 over 3x minus 10 over 3. Yeah, find out the gradient of this line. Gradient of this line is now 1 over 3. Okay, we know gradient of AC and gradient of this line, the tangent, they are perpendicular. So I know I have to use m1 dot m2 equals to -1. Okay, my gradient of AC, let's say I find AC. AC is, gradient of AC is now y2 minus y1, x2 minus x1. This is 9 over p minus 4. So let's take 9 over p minus 4. You multiply with m1, which is 1 over 3. The result should be -1. Now we can cancel this, left with 3. So I multiply over, right? So 3 equals minus p plus 4. Bring over. P is just 1. Yeah, p is just 1. Okay, I've got a better p. Next, I want to find the equation of the circle. Okay, well, the equation circle means equation locus. I already learned about the locus. To form equation of locus, let's say the locus is p, x, y. Yeah, it moves such a way it has a constant distance from fixed point C. But to find the distance, I need to find the length of AC. AC is the radius, right? So let's do one by one. AC will be, find the distance, since I know P is 1, yeah, C is now 1, 7. So I use y2 minus y1 square, x2 minus x1 square. So this is 9 and 3. 3 square is 9. 9 square is 81. 81 plus 9 square root 90. Okay, I've got the radius is square root 90. This is square root 90. So we can say the distance from P to C is constantly square root 90. So use the equation, formula for distance, the equation locus. Remember, P is the moving point, is given by xy. C is a fixed point, 1, 7. We use the formula for distance, x2 minus x1 square plus y2 minus y1 square. The result is square root of 90. Let's square both sides, yeah, and expand this. This is x squared minus 2x plus 1. This is y squared minus 14y plus 49. Square root 90, you square it, you're left with 90. Okay, let's simplify this further. X squared plus y squared minus 2x minus 14y. 1 plus 49 is 50. 50, you minus 90, and 90 you bring over, you're left with 40. So there you go. Your equation of this circle is this, x squared plus y squared minus 2x minus 14y minus 40. Okay, lastly, find the area of triangle OAC. Given that OC, O is the origin. So I know point A, I know point C, and I know point O, right? OAC. My O is probably around here. Let's say O here, OAC. You can use any direction. So I start with O, 0, 0. You can do OCA, OAC is the same. A is 4 minus 2. C is 1, 7. Repeat the first point. Yeah. So this is the formula for the area triangle. We call it a shoestring method, right? Or shoelace method. You multiply downwards. This is 0. 4 times 7 is 28. 1 times 0 is 0. Then you minus this way up. This one is 0. Always remember going upwards is negative. 0. There's a minus 2 here. This one is still 0. So we have 28 minus minus 2. 28 plus 2 is 30. Half of 30 is just 15. So your area is 15 square unit. Okay, and last question. This is from 5, chapter 2, differentiation. Okay. Anne wants to build a closed cylindrical container to harvest the rainwater for her daily use as in diagram 8. N has to custom make the container due to limited space in the house. So the area of the curve is given by this, A equals to 0.8 pi over R. Area of the base is given by this base, and the cover, that means is pi R squared plus pi R squared is 2 pi R squared. So N was informed that the cost of material for the curve surface, for the curve and the base is 125, Rn 125, Rn 200 for 1 square meter. So determine the, they say, okay, the English version is missing. Determine the cost, the function cost, and then determine the function P for the cost of the material, and then calculate the minimum cost. Okay, so number one, we know we have a curved surface at the base and the cover. So we say that the cost for each one, you need to take the area multiply with the cost per meter. So the curve, let's say we start with the top. Okay, maybe I start with the curve. The curve is 0.8 pi divided by R. Then you multiply 125. Yeah, this is the area multiplied with cost per area, 125 ringgit. And the for the top and bottom, we know the area is 2 pi R squared. We multiply by 200. Let me put this together. 200 times 2 is 400 pi R squared. 0.8, if you multiply by 125, you get 100. So this is a 100 pi over R. So this is your cost function. Okay, now then calculate the minimum cost. Okay, to find minimum maximum, of course, we need to differentiate dPdR. So when I differentiate, bring the power 2 down. 2 times 400 is 800 pi. Reduce the copy of R, reduce the power by 1, is R power 1. Now, in the event that R is below, I like to use this formula. For those who don't know, Y equals to K over X power N. So when I differentiate, I put a negative in front, copy K times N, copy X, increase the power by 1. This is faster. So I put a negative in front. This is 100 pi times 1. Now this is 1. So I copy R, I increase the power by 1, I get 2. Yep. Now, next, I'll let my dPdR equals to 0, right? We know at the turning point, on the maximum point, on minimum, your dy dx, in this case, dPdR is 0. I will take 800 pi R minus 100 pi here, R squared. Now, it's up to you. Some people bring over, some people multiply. If you want, you can just multiply by R squared, divide straight by 100 pi to get rid of the pi. So I put a 0 here. 8. When you multiply R times R squared, you get R cubed. The 100 pi you cancel. I can cancel the 2 0 and the pi. This one is minus 1. Yeah. Okay. Let's bring 8R cubed one side, 1 to the other side. R cubed is 1 over 8. When you cube root, you get 1 over 2 or 0.5 meter. Okay. Now, we're not done yet. We are supposed to determine the minimum cost. So to find the minimum cost, we take this R value, sub inside your P. So you got 400 pi. Up to you, you can use 1 over 2, you can use 0.5. Okay, let me just use 0.5. Square root plus 100 pi over 0.5. Okay, calculator, 400. Drop the pi first, times 0.5 plus 100 over 0.5. So this is 400, right? Yeah, but you got to multiply your pi. Let's see. They say use 3.142 or 3.142. There you go. Rm. Okay, let me see. Maybe I've counted wrongly. Your R is 0.5. 400 times 0.5 square plus 100 over 0.5. Okay. That would be 300. You times with 3.142. There you go. RM 942 ringgit and 60 cents. 942 ringgit and 60 cents. So that's your minimum cost. Okay. All right. Part B. If the rainwater flows to the container at the rate of 0.005 meter cube, find the rate of change of the water's height if in the container if n builds the container using that measurement. Okay, so yeah, rainwater flows in at this rate. That means your dV dt is 0.005. Now here's the thing you know. They say n builds the container using that measurement. So we are referring to the container with the radius of 0.5 meter. So the volume of his container is a volume of cylinder given by pi r square h. My r is 0.5. I square it, I multiply by h. So this is 0.25 pi h, right? So we already know the volume of the container, right? But the water that flows in, right, it has, different rate. And the water level will keep going up, right? So you want to find what? You want to find the rate of change in the water's height, or maybe we should say water level, right? So that means you're finding dH dt. Now, before you find dH dt, we can use the chain rule, break it up to, maybe I write dH here. This is dt here. I put a dV. The reason why I put dV because I know dV dt. I need to find dH dV. Well, dH dV can find by taking this function here and differentiate. dV dH. When you differentiate that, because your radius is already a constant, your height is changing. Yeah, if you pour water inside, the height will increase, right? So it increases at this rate. When you differentiate, you get 0.25 pi. Okay. Now, I'm finding dH dt. So dV dH is 1 over dH dV is 1 over dV dH. So 1 over 0.25 pi. I multiply by 0.005. Let us simplify this, everyone. 1 over 0.25. Okay, I'm going to leave the pi last. Okay, I'm going to do the pi last, 0.005. This is 1 over 50 pi. Okay, if you substitute 3.142, yeah, the question asks you 3.142. Let's sub in. You basically take 1 over 50, then you divide by 3.142. It's a very small value. Wow. Shift ENG twice. Just change to numeral form. All right, 0.00637 or 6365 for SF. 0.00635. Yeah, very, very small value. Okay. Now, if you want to write the unit would be in meter and per second. Yeah, actually, unit you don't have to write. No marks even for writing unit in exam. Okay, so we are done for the discussion of this paper. Yeah, thank you very much for watching. I hope you learned something from this discussion. Yeah, see you in the next video.